Hello, everybody. I think we can start. Thank you for coming to the session. Just to double check you are at the right room, the name of the session is Adding JavaFX to your GUI application. My name is Alexey Semenyuk. I'm engineer from JavaFX group. Just a few words to introduce myself. I joined the development team not quite a long time ago, for less than 1 year. Recently doing bug fixes here and there, mostly in the area that allows use of JavaFX with Swing applications and also some other stuff. So, and prior that I worked for several years in Java embedding. So, just to give you an idea of what I'm going to speak today, the session is about the way you can use JavaFX with other UI toolkits like Swing and SWT. So, I will explain in general how this is supposed to be, then say a couple words about the architecture, how it's designed, the source code that supports this feature in JavaFX, then give a review of how it's implemented, show you demos of what we already have in official releases, and show you a demo of what we haven't yet released but plan to do in the nearest future. And then we'll be ready to answer your questions if you get some. So a few words to say about JavaFX itself. I guess that everybody of you, or most of all, know that JavaFX is supposed to be the next generation UI toolkit for development of business applications, sophisticated business applications, as it's stated at Oracle website. So basically, this is the toolkit to develop all the Java applications with graphics. It features high-performance rendering and rich multimedia support, and also has a feature that we supposed to be important. It supports interoperability with other UI toolkits. So what does this mean? This means that you can use JavaFX and other UI toolkits in your application simultaneously. So you can mix content developed with these toolkits in the same application, in the same window. So why do we think that interoperability matters for JavaFX? First of all, as long as the software industry has quite a long history already, and there is a bunch of legacy applications that need to be supported, that need to be updated to meet the present requirements for UI experience. People need to invest some efforts in updating their presentations. But migration from other toolkits to JavaFX might be difficult, so it might be difficult to make this migration in one step. So JavaFX provides features to make this migration in steps, so that you can still use your old UI toolkit and add some pieces of content developed with JavaFX in it. So this is a kind of path to migrate from old UI toolkits to JavaFX. Another reason why we suppose interoperability is important is that for new applications that you want to develop with JavaFX from the very beginning, you might still want to use your favorite third-party components, graphics, or well, you want to migrate to JavaFX, but still want to use all the components. And in this case, the JavaFX also gives you some means to achieve this goal. And another point is when you still want to use your favorite UI toolkit, but you want to add features to your application from JavaFX, like recently added gesture support, support for multi-touch inputs, and feature that was supposed to be added to Swing, but right now available only in JavaFX. This is like HTML rendering your application. So all these reasons were supposed to be important for support of interoperability in JavaFX. So what's the goal for us in order to support these features? First of all, we want to provide a public API to allow JavaFX content to be embedded in third-party UI toolkits, and also API to embed JavaFX content in those toolkits without any hidden stuff, without any secrets. So it should be public API. Then this API should allow application developers develop with JavaFX, so that not to care about the environment where this content is about to be used. So it should be no difference for application developers whenever this content will be used in embedded JavaFX mode or in standalone JavaFX application. And we also want to minimize the performance penalty for embedded JavaFX content. So this is the goal behind the interoperability feature in JavaFX. So this feature was initially introduced about 1 year ago. The previous Java 1 we announced support to embed JavaFX content in Swing applications, and also at the time announced the support for embedding JavaFX in application developed with SWTA UI toolkit. So this is what we have now. So we allow embedding JavaFX in Swing and SWTA applications. So the year has passed, and since that announcement, we got some updates to this component. So right now we fully support drag and drop feature for embedded JavaFX. That was not previously available. It was rather tricky to implement. That's why we didn't have it from the very beginning. Also, we did some work on improving the performance for embedding JavaFX, and resolved some threading issues, as JavaFX lives in its own threads. There are multiple threads, and bugs live here and there, and there is also always what to fix in this area. So we support embedded JavaFX on all platforms where we have the JavaFX itself running. So it's Windows, Mac OS X, and Linux, and also did some improvements and bug fixes in this area. Just to demonstrate what I'm talking about, I'm going to show you a small demo. So this is Swing Interop demo. It's not new. It's available on download already. So here we have the Swing application with JavaFX chart and Swing table. So we can change value in Swing table, and the chart will be updated. And on the second tab, you can see the web page displayed. It runs inside of web node JavaFX control, which lives inside of JFXPanel. This is a Swing controls that runs the embedded JavaFX inside of it. So, and right now, so this has been already available for 1 year, but recently, as we added the drag and drop support for embedded JavaFX, you can now drag something in. Just to demonstrate it to you.
Question.
Sure.
The JTable and the JavaFX chart, are they put inside the JFXPanel?
No. The JFXPanel runs the chart only. So it's
So the tape is still runs in JFX.
yeah. Just to show you the drag and drop feature. Here it goes. So this is what we have in JavaFX 2.2 and a few words about the architecture, how embedding is designed. So when thinking about how to implement this, we had basically two opportunities: lightweight embedding and heavyweight embedding. Heavyweight embedding is when you have the placeholder for embedded JavaFX control managed by the platform. So when the placeholder control has corresponding platform-specific handler and not managed by the UI toolkit where you run the embedded JavaFX stuff. And lightweight embedding, it's a little bit opposite. It's when the placeholder is managed by the specific UI toolkit. So the only benefit of heavyweight is from the implementation point of view, as it requires less coding and simpler to implement. And the drawbacks is that it's harder to use such heavyweight placeholder, and with this approach we have a limited set of interoperability features. So we don't have that translucency support, we don't have the flashy efforts and all the good stuff that JavaFX provides. And we have chosen the lightweight approach. We have it for JFXPanel. So it required a little more efforts from the implementation point of view, though it's easier for application developers to use it, and we have better interoperability features with this approach. So we have the translucency support, better scrolling, and effects. So the reason why I'm basically talking about how it's designed and how it's implemented is because as JavaFX itself is going to be open sourced, and right now we are in the middle of open sourcing. So maybe you would like to provide your own bridges of JavaFX to other toolkits. So I guess that this information may be interesting from you from this point of view. Here is the picture of how it's designed. So how JavaFX embedding happens. So if we have the Swing or SWTA as a hosting toolkit and JavaFX as a hosted, we have flows of events and graphical content going between them, and these flows pass through the abstraction layer. So this is a piece which requires more coding, as I said, for lightweight approach. So when the events go from the host toolkit, they dive into abstraction layer where they convert it into the format that is recognized by JavaFX. And in reply, JavaFX generates the graphical representation of the scene and passes it through the abstraction layer back to the host toolkit. So having the abstraction layer, it's possible to embed JavaFX in almost any UI toolkit of yours. And in case of reverse embedding, where we have the JavaFX as a hosting toolkits, things look similar, but in fact things a little bit more complicated, because in this case it's not always possible to provide the embedding of content developed with other UI toolkits on JavaFX. It depends on whenever this toolkits provides API for putting their stuff into environment provided by JavaFX. So when they run standalone, they depend on the platform, and when these toolkits run inside of JavaFX, it's necessary to provide the relevant environment. And whenever it's possible to provide such environment depends on those toolkits. So that's basically all about the architecture, and just a few words about implementation. I will speak a little bit more about JFXPanel because I'm working on this component and I'm kind of more familiar with it. So this is, as I said, an entry point for embedding JavaFX in Swing. It is a lightweight J component, and basically all it does is overrides the event handlers where it catches the events from Swing and the AWT and passes them to the abstraction layer where the rest magic happens. Right now we support the JFX panels, multiple JFX panels in your application, so you can have many of them. Also you can run embedded JavaFX with standalone. So we suppose that the current state of JFX panel allows to cover all the possible cases of the use of embedded and standalone JavaFX in your application. So threading, this is interesting matter as the JavaFX itself, it runs in multiple threads. We have a thread where we have the event queue and we have the rendering thread, and with Swing it's also similar. We have the thread that consumes events from the platform, and we have a thread where all the Swing objects live and event queue. So all this stuff needs coexist. And it's necessary to obey the rules that Swing objects can be accessed only from the Swing thread, and JavaFX object can be accessed only from JavaFX application thread. So the JFX panel itself, it's not thread safe, and if you want to access Swing objects from JavaFX content, from say event handlers of embedded JavaFX content, you need to use specific API. This is you need to use invoke later method from Swing utilities class, and the same way, if you want to access JavaFX, embedded JavaFX from Swing, say you override some event handler of JFXPanel and want to control JavaFX send from that event handler, you need to use run later method from the platform class. So these are interesting things to notice and to remember on the case when you use the embedded JavaFX. So here is this picture how the input events go in case of embedded JavaFX. So here we have the AWT toolkit thread that obtains events from the platform, AWT event dispatch thread, and JavaFX application thread. So when the AWT toolkit thread obtains event, it constructs a Java object with the data and asynchronously schedules it into the event queue running on AWT event dispatch thread, where this object, when this event object is dispatched to JFXPanel, and in one of its event handlers, this object is unpacked and sent asynchronously to JavaFX application thread. So, and finally, this object going through the abstraction layer reaches the scene graph where it is processed. So a little bit complicated, and in case of drag and drop, things are even a little bit more complicated, because in drag and drop it's necessary to send replies to the system on events that it sends to JavaFX. So in case of drag and drop, we also send replies from JavaFX application thread to AWT event dispatch thread. And for drag and drop, we kind of break the rule of Swing not to block the AWT event dispatch thread. This is this is what we have to do. So block the thread and wait for replies from JavaFX application thread. But this is true only in case of drag and drop. So how painting happens? Well, with a lightweight approach for embedding that we choose for JFXPanel, we need to render the whole JavaFX scene into a back buffer and then send this back buffer from JavaFX thread to AWT event dispatch thread where it's get rendered on the screen. So this is the kind of payment we made for allowing all the benefits of lightweight embedding, where we have this fast scrolling, where we have the effects and ease of use for application developments. Actually, this results in some performance penalty, not very high from the frame per second point of view. The embedded JavaFX runs about 10 or 15% slower than a standalone one. So that's basically all about the JFXPanel. A few words about FXCanvas. So this is component for embedding JavaFX in SWTA applications. It has the similar design to JFXPanel. It also forwards the mouse keyboard events like JFXPanel to embedded FX and does the same stuff. The only difference, but very important, is that there is no need to asynchronously communicate with embedded JavaFX. So you don't need to call run later method of the platform class in order to communicate with JavaFX objects from SWT application. This is because they all run in the same thread. So this and the SwingNode is a new thing that we don't yet have in releases. This is an entry point for reverse embedding, for embedding Swing content in JavaFX application. So this feature is not yet publicly available. It exists as an early prototype, so we are still evaluating the design and trying to understand whenever we can do everything we want from it. So right now we support only the simple input events, so mouse, keyboard, no drag and drop, no sophisticated stuff, and we support rendering. So that's not little already. And just to show you how it works. So here is the standard JavaFX ensemble application, slightly modified. You can see Swing content running in it. This is Swing set to almost standard demo applications that shows the features of JavaFX. So this is not a picture, this is not a video. It actually works. So this is what we have as a prototype and what we plan to put in one of our following releases. So a few words about our plans on interoperability feature in general and some details. So we plan to focus on interoperability with Swing. This is our priority. As the JFXPanel itself seems to be finalized, we don't expect to add new features to it. We plan to put more efforts on SwingNode development. We would like to move it from the state of early prototype to release candidate as soon as possible. We also will maintain and improve JFXPanel itself. We don't give up maintaining of SWT, JavaFX and JavaFX interoperability. We're still working on this in this area. We're thinking about providing support for embedding SWT content in JavaFX, so SWT node. And as I said already, we are thinking about open sourcing the code for interoperability feature in JavaFX. So once again, if you think that adding JavaFX to your application is a good idea, and if you still want to use your favorite UI toolkit, which is not a Swing or SWT, even, I don't know, any kind of UI toolkit, you may think about providing your own bridge for JavaFX and that toolkit. So as for our plans for SwingNode, we still not yet settled with the design. That's why I don't speak too much about it, just showing you the demo. So as we are not sure how it will look like, because when it's only prototype, it's one thing, and when it's coming to the release, things may be totally different. So like with JFXPanel 1 year ago, we still need a lot of features to be implemented, like drag and drop, input methods, and modality support. Currently, SwingNode runs only on Windows, so we need to make it functional on Mac OS X and Linux, so all platforms where JavaFX lives. And definitely performance optimizations. Currently, it doesn't satisfy us. So what we have. Well, that's basically all. Here are some general JavaFX links that may be found, that you may find interesting, and I think that I will keep this slide on, and now I'm ready to answer your questions if you have some. No questions?
Can you speak to why should we add JFX to our GUI? If we've got an application running in Swing, it's been running in Swing for years, why should we move to JavaFX?
If you need, for example, to run HTML in your application.
Because Swing is not developing anymore. Yeah, but I think the example with the chart that was quite good. I mean, if you have good components to display charts, why not use them?
Well, Swing is not going to have a support for multi-touch, and in JavaFX we have support for multi-touch. So if you want to develop for hardware that supports multi-touch, you might be interested to move into JavaFX, or at least you might be interested in SwingNode feature that will allow you to still use JavaFX, and as long as SwingNode is a first-class JavaFX object that supports multi-touch, you can provide multi-touch support for your Swing application. But this is a little bit strange when you have the whole application, Swing application, wrapped inside of JavaFX and use only multi-touch feature from JavaFX. Yeah.
Yeah, the other reason to move to JavaFX is because of FXML, which helps you separate the view from controller.
Yeah. We have a scene builder, an application that helps you to design the graphical part, which you don't have in Swing. Yeah.
Thank you, that's helpful.
The SwingNode, is there like a timeline that you share? Like when should we expect that?
I don't know. I think that, well, I really don't know when we are ready with the release of this feature. It's working right now, but you know, from the time when it starts working till the moment when we can release it, it might pass some time.